Welcome to the compound interest lesson. So last day we did actually look at compound interest. So if we take a look here, we did simple and compound. And so basically simple again was just where the same amount would be added on to a certain amount of money that you invested. So 700, you get 28 every year. Okay, so the interest never changed. But then we looked at compound interest. And this is where you start with 700, but then you keep accumulating interest on the amount that you deposited plus the interest that you make every year. So instead of bringing 700 to the next year, you would bring 728. Okay, and then you calculate interest on that. So again, your money was growing a lot faster with compound interest. But making this table though was a little annoying. It took a little bit of time in order to get to your final amount of money that you ended up having in your account. So I just wanted to show you that there's actually a formula that you can use, and that's what we're going to learn about today. Okay, so here is so I did have it on the note last day just to, as a preview, but we're actually going to use this today instead of using that table where we fill in a whole bunch of numbers and so forth. Okay, so A is the future amount. So this could be a loan that you borrow from the bank, or it could be money that you leave in the bank. So we're looking at what amount will there be at the end. P is the principal, or the initial amount you start with, okay? And I is the interest rate, but it's going to be based on, we're going to have these compounding periods. So basically the interest can go, like before we would always look at it as the interest went on once a year and that was it. But you can actually have interest go on at different amounts per year. So you can have it go on monthly, you can have it go on weekly, twice a week, twice a month, daily, okay, if you get a really good account and so forth. So we are going to look at the interest rate per compounding period. So depending on how many periods you actually get the interest, okay? And then we looked at time before as well. That was in years. So again, you can have various, I guess, how many times the interest goes on. So we're going to be able to calculate how many compounding periods there are today as well. All right. So in order to do that, we need to calculate out, just kind of figure out how do we calculate I and how do we calculate N before we actually get to using this formula here. Okay, so to warm up, we're just going to go through and just kind of look at these words, because what you're going to find today in the questions are things like, you have a loan at 15% compounded annually. Okay, so we saw that last day too. Like it was, your Larry wanted to put some money away, so you had 4% per year compounded annually. So this compounding word was there. So we're going to look at that today and just translate annually, semi-annually, quarterly, what these mean, how many times a year that is, and then use it to help us find I and N, okay? Okay, so we're just going to go through here and look at, so when I say I'm going to give you money annually, so what does that mean when I say annually? Okay, so annually means yearly. Yearly. It's the same, it's a fancy way to say yearly. So how many times a year is that? Well, that's once a year, okay? All right, the next one is if I am going to give you money semi-annually. So what does that mean? So semi means like half, right? So semi-annually is half the year. So if it was half the year, that would be like 6 months, right, out of the year. So how many times a year? So if we did this for a whole year, so semi-annually 6 months, so we need another 6 months, right, to make a year. So there's two, so think of it as if I'm going to give you money semi-annually, I'll give you money at 6 months, and then I'll give you some more money at another 6 months. So I end up giving you money twice in 1 year, like that, okay? All right, quarterly. So if I give you money quarterly, okay, so if I take a year and break it into quarters, you'll end up with like every 3 months I'm going to give you money, okay? But quarterly, so if I give you money every 3 months, so we keep doing that, and then after 4 times doing it, you'll end up with a year. So quarterly means 4 times a year, okay? And then monthly, how many months are there in a year? 12. So if I give you money monthly, that means I will give you 12 payments a year. Okay, weekly, so there's 52 weeks in a year. So if I give you interest every week, then I'm going to give you 52 payments of whatever the interest was. All right, and if you happen to find an account like this, I'm sure there's one out there, where I'm going to pay you interest daily for just keeping your money in the bank account. So that will be 365 times in a year that I'll have to pay you money for keeping your money in the bank, okay? All right, so now that you know, can kind of translate these into how many times a year, that's what you're going to use in order to calculate the interest, okay? So you're going to find, like in a question like one example one, you're going to know there's, 15% interest, right? So if I'm going to give you 15% annually, that means I'm going to pay you once. So all you do is you take your percent and you divide by 1, okay? Because so you just take your interest and divide by 1 because I'm only paying you once. Okay, but then if I pay you semi-annually, so again, say the interest is 10%, right? So if I pay you once, I'll pay you 10%, okay, in the year. All right, so if I'm going to pay you semi-annually, right? So what you're going to see in a lot of the word problems today, you'll still see the word per year. So interest rate per year, like that, but then it'll say compounded something, okay? So interest rate per year compounded semi-annually. Interest rate per year compounded monthly. So basically in the whole year, you're supposed to get 10%, but I can break up the 10% into depending on how many times I'm going to pay you out. So if I'm going to pay you out semi-annually, what I'll do is I'll pay you 5% the first payment, and then I'll pay you another 5% the next payment, like that. Okay? And if it was quarterly, so then I would have to break 10 into 4 pieces. Okay, so then I would pay you 2.5 after 3 months, 2.5 again after 6 months, and so forth, right? So that I end up eventually paying all together 10. So what you're going to do today is whenever you see compounded whatever it is, you're going to take your interest rate, okay, whatever it is, the percentage, and you're going to, and remember to change it to a decimal, and you're going to divide it by one of these numbers here, depending on how many times it's compounded. So semi-annually, because it's twice a year, I'm going to divide by 2. Okay, quarterly, divide by 4. Monthly, so again, if I had to pay you 10%, if it was monthly, I'm going to divide the 10 by 12 to figure out how much I should pay you every month, okay, for the whole year up to a year, right? And then same thing, if it was weekly, then I divide by 52, and if it was daily, I divide by 365. Okay, so that is how you find I. Okay, so you take your interest and you divide by how many times I will pay you out the interest. Okay. Okay, so now we got to figure out n. N is the number of compounding periods. So basically, we've already talked about how, when it says annually, something like how many times a year that is, right? So I'm going to pay you out this much interest, depending on how many times a year it is. So now, if I'm paying you interest, right, and in different amounts here, okay, I want to know how many times I do that overall in the whole term of the loan. So basically, if you keep your money in there in the bank for like 5 years, and you were getting interest like 4 times a year, like that, if you keep it there for 5 years, how many times did I just pay you out the interest? Okay, so that's what we're figuring out with n. It's like how many times did a payment go to you? Okay, where here it was like what was the interest at every single payment that I sent to you per year. Okay, so what you're going to do here is you're going to take the time. So here, like you were going to divide the, so you take the interest rate, okay, and then you're going to divide by these numbers. So here you're going to take the years, the time, okay, that'll be provided in the problem, and you're going to multiply by, well, if I keep my money in there for 1 year, so then really you're just going to be multiplying once, right? You're just going to have be paying out or get the interest once. If it's semi-annually, how many times do you get paid interest? Well, you multiply by 2, okay, because you get paid twice. And so forth. Quarterly, you multiply by 4. Monthly, 12, okay. Weekly, 52, and yearly, 365. So hopefully you can see where these numbers came from. So again, if for example, if I kept you kept your money in the bank for 5 years, okay, and you have it compounded quarterly, okay. So if the money is compounded quarterly, how many times is that that you'll actually get paid in 5 years? Well, in each year you get paid 4 times, right? 4 times a year. So if you do this for 5 years, do you see how it's like 4, 4, 4, 4, 4, like 5 times, right? So you end up having 20 payments of whatever the interest was. So that's what this N is. It's kind of like the time, but it's like how many times does the money go on to that, or does the interest go on to the investment that you have in the bank? Okay, I is just you're breaking down the interest so that you're paid out. If it's 10, you paid out 52 times in a year. If it's 2, so again you get paid out twice, but you're going to break the interest into 2, okay, so that it's distributed through the year. Okay, so anyway, so those are the rules that you can use and you can kind of use this table to reference it, but I think we need to look at an example and then it'll make better sense here. Here's example 1. So we are going to use the interest rate of 15%. Compounded blank. So compounded, we're going to fill in these words here. So 15% compounded annually, 15% compounded semi-annually. So basically knowing that information now, can you calculate I? Okay, according to what we did here. So remember I, you take the interest rate as a decimal and you divide by whatever the period is, okay? All right, so again, 15%, I'm going to change that right now. So 15%, to take it and divide by 100. And then you get 0.15 like that, okay? All right, so that's what we're going to work with here. So if it's annually, all you're going to do is you're going to go 0.05, okay, whoops, 15. So you have 15% to pay out in a year, okay, but it's annually, so you only do it once, so that's why we divide by 1, and you get 0.05. Okay, so again, this is about you taking your interest rate and breaking it up over the year if you're going to be paid out several times, okay? But annually, it's only paid out once, so interest rate is 15%. Okay, so here's the next one. So again, we have 15%, but I want to be paid out semi-annually, so that means twice a year, okay? So we're going to take the 15 and chop it up so that it's twice a year. So what would half of 15 be? So you just take this, and again, if it's twice a year, you divide by 2. Okay, and then you'll get 0.075. Okay, so and then don't round up, just keep all the digits here. All right, so now it's quarterly. So if I had 15% and I want to be paid quarterly, so how do I break 15 into quarters? Okay, so you divide by 4. So when you do that, sorry, the number is getting tinier and tinier, just write small. You end up with this much. So every 3 months, because we're doing quarterly, right? So if we do every 3 months, so the first 3 months we'll get paid this. The next 3 we get paid this, okay, and etc. And then when you get to a whole year, then you'll get to the 15% total here. All right, so here's the next one. So again, we have 15%. We want to be paid monthly. Okay, so what are we going to break 15% with? 12, right? So you end up with that amount there. Okay, all right, keep going here. So okay, so the interest rate is 15% there, and we are being paid out weekly, so that's 52. Dang, we're getting to a super tiny number here. So we're just gonna 1, 2, and then one more. So it's 288, I guess, here. Okay. And there's a lot more decimals, but I just rounded it. All right. So today, when you're working with these numbers, carry at least, I don't know, maybe even 4 here. Maybe I'll write a couple more here. Okay. These other ones were nice and neat. So I just stopped at this number of decimal places. All right. From there, last one. So 15%. If you were going to get paid 15%, but it's compounded daily, that means you have to break the 15 into 365 pieces. Okay, and then here's this tiny number here. Okay, so 1, 2, 3, 4. All right, so there's your I values. Okay, so now that we've figured out how to kind of distribute the interest onto our loan or how much money we've invested, we need to look at now how many times does this interest get thrown on, okay? All right, so example 2 here, we're going to take, okay, so say how long you want to leave your money in the bank is 7 years. And again, that means you're not going to touch it. You're not going to add more money to it. You're not going to take money out, okay? You're just starting with a certain amount, dumping it in, and leaving it there for 7 years. All right, so if the interest is compounded at these various compounding rates and so forth, we need to figure out, our periods, we need to figure out, okay, how many times will that be in the 7-year period that we're leaving our money in there, okay? So that's what we're looking at. So if you, so it doesn't matter what the interest rate is and any other information right now, if you know that you are getting interest annually, compounded annually, right? So that means that in 1 year you get paid once. Okay, so you get paid once. So if you leave your money there for 7 years, what you're going to do is you just multiply by 7 like that, and you get 7 times. Okay, so what you're doing here is that you are, N is found by taking, okay, the number of compounding periods, okay, times the number of years. Like that, okay? So that's what you're doing right now with these calculations. So it's like, how many times a year are you getting the interest put on? Once a year, okay. And then how many years are you leaving the money in there? So you go 1 times 7 is 7 times. Okay, so now that we have our N here, our formula, we're going to calculate that. If you wanted something like that for the previous question where we had to find I, so I'll write one right now. So you have I is equal to, so you took your interest rate, okay, and it was as a decimal, right? And then you divided by the number of compounded periods. Okay, so that's what you were doing here throughout this table. So you always took your interest, you divided by, if it's semi-annually, twice, quarterly, 4 times and so forth. So that's the formula that you should use here when you're finding I. Okay, so when you're finding N, you're just taking how many times a year that you get the money added on, and then if you leave it there for 7 years, well then you multiply by that many years, and so then altogether, the amount of money that you left in the bank, you're going to add interest onto it 7 times. Okay. All right, so let's go through and finish off this table here. Okay, so again, semi-annually. So how many compounding periods is that? In 1 year, how many times is that? So that's 2. Okay, and then how long are we keeping? So if we know we're getting paid twice in a year, and then I leave it there for 7 years, how many times is that? So we're just going to multiply by 7 to get to 14. Okay, so again, I keep using 7 years because that's what the example is here. All right, so quarterly. So again, how many times a year is that? 4. So if we do that 4 times a year, but we do it for 7 years, how many times? 28. Okay. All right, and if we do these out of order, what if it's daily? Okay, so daily means the interest gets given to you every day in a year. So 365 days in a year, so 365 times in 1 year. So now if you do this for 7 years, you're going to multiply this by 7. And you get 2,555 times the interest will get plunked onto the investment. So that's why this daily interest, if you can get something like that, that's a great account to have, okay? All right, and then there's, okay, let's do monthly now. So again, monthly is 12 times a year. So if you know in 1 year, 12 times the interest goes on, but leave it there for 7, how many times is that? 84 times. Okay, and then weekly, that's 52 times in a year. And again, if we do this for 7 years, it's 364 payments, okay, of the interest that will be given to you. Okay, so all right, so there are the 2 formulas, and so I want you to have those out so that you can use them as a reference when you're going through the problems today. Okay, so we'll move on to the next example here. So with this one here, example 3, it's just more kind of a warm-up on just reviewing how to go about calculating stuff and respecting BEDMAS, okay? So remember brackets, exponents, multiply, divide, okay? So just, and then add and subtract. Make sure you follow the order of operations here, okay? So we will start off with this one here. So what I want you to do is I want you to deal with the brackets first here. So this part here. Okay, so yeah, so let's add the stuff that's in the brackets. We'll write everything else out. So this becomes 1.02 when you multiply it out, okay? Or sorry, add them together. All right, so the next step here is to do the exponent, right? Brackets, exponents. So on your calculator, get out your scientific calculator, and we're going to put in the 1.02 to the power of 3, okay? So the button on this calculator here is this roof button, but just a reminder that, you can use the roof button. So you can use the roof button, or there's X to the little y, or it could be like y to the little x, like that, okay? So depending on if you're using your phone or if you're using yeah, an actual calculator. So again, the calculators vary and so forth. So yeah, just one of those buttons there. So we're going to go 1.02 to the exponent button 3, and then hit equals, and then you'll get this number 1.06, like that, okay? So again, I could write that down here. So it'll be 500 times 1.06. What else was there? 1208. Okay, but once you find that part, right, I'm okay if you just like keep that on your calculator and then you go times 500 instead of like writing it here on the paper and then just taking more time and so forth. Okay, so just, yeah, use that number there, times the 500 equals 530. And now remember, this is we're going to be dealing with money today, so I want you to be rounding to 2 decimal places. So if you take a look here, so it's 604. I want to keep the 6 and the 0, right? So I'm going to look at the first number. I'm going to drop off 4. It's not bigger than 5, so I'm going to leave it as $530.60. Okay, and again, I guess you didn't know if this question was about money and so forth, but I just oops, added the money sign so that you get, yeah, just used to doing that, because all the questions that you're going to be looking at will deal with money. So let's move on to the next one here. So again, just go through, follow BEDMAS. This is why we've been practicing this, just to make sure we don't make any mistakes with BEDMAS this year, okay? So again, I know you might be tempted to go this times 1 and then add it to this and eventually take the exponent, so just going left to right, don't do that. Make sure follow BEDMAS. So again, we're going to go through and calculate out this step right here, okay, first. So when we do that, that just cleans up to 1.041 to the exponent 5. Okay, so the next step is take care of the exponent. So let's do that on our calculator. So we have 1.041 to the power of 5, enter. Okay, so we get 1.22. Okay, so again, I'm just going to write it here, but I don't want, you don't have to. Okay, 1.22, 513, etc. Keeps going. All right, so just keep it in your calculator. Keep the number in your calculator, and then now you're going to do the last step, which is to multiply the number that was in front. So that's so you go times 12500 like that, enter, and then you end up with a lot of money here. Okay, so oops, so you have 15 here. I'll write over here. 1528, right? $15,281. Oh, let's practice rounding here actually. So we have to keep all of this, and we want 2 decimal places, so 41. Okay, so we're going to look at the first number we're going to drop off. It's an 8, so that means we got to round the 1 to 2. Okay, so 281.42. 42 cents, like that. Okay, all right. So yeah, again, be careful with rounding. You want to get those perfect, and then you can just practice and put the $sign in right now. All right, so now that we just did our review of BEDMAS, we can actually tackle some compound interest questions today. So let's go to example 4 here. So just read it through, and then again, just like we did last day, I want you to write down all the stuff that you have. So G's for given. Okay, and I want you to go through and list off all of the information that you have and then what it is that you have to find. Okay, so again, as you go through, you can even write the letters on it. So again, here's our formula. We have A equals P, okay, times 1 plus I, N. So we were just practicing trying to figure out I, trying to figure out N, and now we're going to use this formula here. Okay, so he wants to invest 700, so he wants to put 700 into the account. So this is your principal amount, okay? So you're going to write in, this is P, okay? And so you want to keep your money in there for 5 years. So that's kind of like I guess we'll just write T for time. And then the interest rate, okay, is 4% per year compounded annually, okay? So there's kind of your interest rate, your I, okay? Or it has to do with I. So we're just going to go through here. And so we know P is 700. Okay, and then the other letters are I and N that we have to figure out. So so remember it's the interest rate. It's going to be the interest rate as a decimal divided by the number of compounding periods. So I'll call it CP, compounding periods, okay? All right, so we have 4%. So we're going to change 4% to a decimal by dividing by 100. Okay, and then we get 0.04. So the interest rate is 0.04 divided by, and then the number of compounding periods is right there. Okay, this is the compounding period. So annually, so that's once a year. So our interest rate that we're going to work with today is 0.04. Okay, and then from there, we need to figure out the N value, okay, which has to do with the times, the number of times, right? So we're going to write that in here. N is, remember, the number of compounding periods times the number of years. Okay, so the number of compounding periods is, okay, it's annually, right? So we need, it's once a year. Okay, and then how many years is Larry keeping the money in this investment? For 5 years. So we're going to multiply by 5 here. So we end up with 5 times. The money gets compounded 5 times. Okay, so our goal here, what is required, is how much money are you going to have, okay? So that's your A value that you have to find, okay? All right, and grasp. So again, given, required. A means analyze. How are you going to go about figuring this question out? So I always think of it, it is the equation step though. This is where I write the equation. This is where my plan is of how I'm going to go about solving. Okay, and then S is to actually solve it. So actually put the number in, put all the numbers in that you know, and calculate the one that you don't know. Okay, so here, so again, that was supposed to be an S. It doesn't look like one. All right, so you are going through, okay, and filling in this formula here. So we know the principal is 700. Okay, 1 plus I, so the I that you calculated is 0.04. And then N, its exponent, is 5 here. Okay, all right, so now we're going to go through and we're going to calculate this out. So again, BEDMAS says do the bracket first, so we'll clean this up. Okay, and then BEDMAS says do the exponent. So grab your calculator. I'm just going to delete this stuff out of here. Okay, so we need 1.04 to the exponent 5. Okay, so that's 1.2165, right? So it's in your calculator already, and then all you have to do is hit times 700 like that. Okay, and then we will get 851. So I'm going to write out all the decimals here so you can practice your rounding. So 851, and then it goes 65703.1. That's what it's on the calculator, okay? But remember, this is money, so you need to round to 2 decimal places. So what you're going to do here is, you know you have to keep 2 decimal places. So you know you have to keep this 5 and this, this 6, okay? So what you're going to do is you're going to look at the first number of all the numbers you're going to drop off, because we're going to drop all of these off here. So if this number is 5 or bigger, I want you to round up. Okay, so I want you to round this number up, okay? So this is like, we need to keep all of these, and then this is the last one we have to keep. So we look at the first number here that we're going to drop off. If it's 5 or bigger, I want you to round up. Okay, if it's not 5 or bigger, so it's less than 5, so it's like 4 and under, okay, then you're going to keep it the same. Okay, so yeah, so again, if this was like a 4, you would just keep it 65. But because this is 7, which is 5 or bigger, we're going to bump this up to 6. Okay, so now you have 800, so it's $851.66, like that. Okay, so that's your final amount. Okay, so we have Larry wanted to leave his money in the bank for 5 years at an interest rate of 4% compounded annually. So in the end, after the 5 years, he's going to have $851.66 in the account when he started with 700. So he made some money. So it's good. All right, so that's what you're doing today. You're just going to go through and you're going to use the compound interest formula here. And it's just a lot quicker instead of filling in a table with like multiple values. So again, like last day, I think I gave you at the most 5 years. So there were, still a lot of calculations, but it wasn't too bad. But if we are looking at keeping our money and saving it for 30 years, making a table with 30 years of worth of values is a lot of work. So that's why this formula is a great one to use. You just got to be careful with following BEDMAS when you're calculating out the values, okay? All right, so let's go to the next one. Okay, so determine how much money you will have if 500 is invested for 6 years at 14% per year, compounded semi-annually. Okay, all right, so here's the money that we are investing. So that's going to be the principal. We will also, I'll keep saying present value. Okay, so that's the principal, but it's also the present value. Okay, so this is the amount that we have right now. From there, you're investing it for 6 years. That's the time. Here's kind of the interest rate. I'll just write R for now because we're going to find I. And then here's the compounding period. Okay, so we'll call it CP. All right, so we're going to go through and kind of write down all the things that we know. So we know the principal is $500. Okay, so that's the present value. All right, we know the interest rate, okay, is 4%, but we need to figure out I, which is, again, the number of the interest rate divided by the number of compounding periods. So that's what we have to do. So take 4%, change it to a decimal, okay, by dividing by 100. Okay, so you're going to take the 4% as a decimal, and then you're going to divide by the compounding period. Okay, so the compounding period is semi-annually. So how many times a year is that? That's 2. Compounding period is 2. So you're going to divide the interest, 4% by 2, so that because I'm going to give you interest twice a year, okay, so you're going to give me 2 at one point and then 2 at another point. So if we divide 4% by 2, you'll get 0.02. Okay, so that works out to 2%. Okay, so semi-annually, so 6 months, I'll give you 2%, and then the next 6 months, I'll give you another 2% to make a total to 4. All right, and then, N. N is how many times do you actually am I going to give you the interest, okay? So again, in 1 year, okay, I'm going to pay you twice. But how many years are you keeping your money in this account here? Okay, so if you look through the time, the time was 6 years. So you're going to keep it there for 6 years. So you want to multiply by 6. So altogether, if I'm going to give you interest twice a year, okay, and then you keep your money in there for 6 years, that's 2, 4, 6, 8, 10, 12 years. Okay, all right, so now we know our P, I, and N. We need to find what? How much money will you have? Okay, so that's the future value, okay? That's the final amount. So that's what you have to find. All right, A is analyze. Analyze the situation, figure out what you're going to do here. So we're going to use our formula here. Okay, you don't have to memorize it. I'll provide that to you on tests and quizzes. Okay, so from here, I want you to plug everything in that you know. Okay, so now we're going to the solve step. We're putting our plan into action here. So we have 500 for the principal, and we have 1 plus the interest rate is 0.02 like that, and then the n is 12, the exponent is 12. Okay, all right, so again, when you were writing this part, if you wanted to just write it as 1.02 right away, then you can do that. Okay, otherwise just be careful here. Make sure that you are using the brackets or cleaning up the brackets first. Okay, and then from there, use your calculator and calculate 1.02 times 10 to the 12 here. Okay, so you have 1.02 to the exponent 12. Enter. Okay, so there's your number, 1.26. Okay, so you don't have to write it down, just keep it in your calculator, and now go times 500. Okay, all right, so I'm going to write in all of those digits to help you round. Okay, so I wrote all the digits off the calculator, so I'm just going to help you practice rounding now. All right, so again, it's money, so you need to keep a couple decimal places. So 2 after the decimal here. So, 1 and then 2 here. So this is the number. So you want to keep all of these digits, 634, and then 0.12. Okay, you want to keep this 2, but you just want to look at the next number beside the 2. And because you're going to dump all of these numbers off, okay? So you just look at the first number in that pile there, and you're noticing that, it's a 0. So if it's 5 or less, if it's less than 5, you don't round, okay? So we're just going to keep this as 12, okay? So it'll be $634.12, like that. Okay, so that's the final amount that you will have if you leave 500 in there for 6 years and the interest rate is 4%, compounded semi-annually. So again, you're getting interest paid to you twice in a year. You're going to make money a lot faster than you would if it was compounded annually, okay, which is what we did up here. Okay, so Yeah, so again, you know how I was saying, compound interest is better than simple interest. Well, today what you're looking for is if you can get greater compounding periods, greater interest rate, those are always better for you as well, okay? Okay, so here's example 6. So far we've looked at questions where we put our money into the bank and then we leave it there, we get interest on it, and then we take it out later and then we have more money. So it's fantastic, okay? So that's when you have an investment. So we've been using the word investment, and so forth. So now you can actually, it's a similar scenario where if we can borrow money from the bank, okay, so basically they'll give you a certain amount. So like here, draw a picture here, whoops. So we'll have a nice gold bank. That's hilarious. Okay, so we have a bank here, and they're gonna give you $5,000. Okay, so you're gonna use it. Like here, Alice is using it to start a small business and so forth. So anyway, the so now you have this money in your pocket. Okay, so this is you. It's with you now. Okay, and so when you have it in your pocket, it's almost like the bank has now placed it with you, where it's going to get interest on it. Okay, so and then basically it has to be returned back to the bank. Okay, so I don't know, maybe we'll draw it like this. So we have to return it back to the bank eventually. Okay, so before when we were looking at, like if we were looking at, putting our money in the bank, so this would be us, we would put our money into the bank, right? It would get interest on it, like that. And then we come back after, whatever, 5 years, and we take it out again, and then we have more money, so we're pretty happy, okay? So, so that was like when you have an investment. Okay, so if you have a loan though now, okay, so this is something you might do because you want to buy a house or you want to buy a car or you want to start a business and so forth. So you'll get a loan, and again, this is the bank here. Okay, so you can take money from the bank and use it and then give it back later. So so what's happening here in the loan situation is that so you're going to take 5,000. The bank is going to charge you interest. And so when you give it back, okay, you have to give back more than 5,000. So it's like here you had $100, okay? You put it in the bank and they gave you interest. Like maybe they gave you like $25 in interest, right? So when you took it back out, you were now at 125. So you're pretty happy because you made some money. You didn't have to do anything. So the same idea works here. So you have to, I don't know if the going around in a circle is helping, so maybe I'll draw like this. So you have to borrow 5,000 from the bank, and while you have it, interest is going to be added onto it, okay? So when you give it back to the bank here, after like the term is up, so now, so say like the interest was, I don't know, 25 bucks as well. So then when you give it back to the bank, you now have to give them back more than you borrowed. Okay? So that's what's happening here with the loan situation. So it's kind of like you leaving it like in the bank and you make money. This is more like now the bank's making money. The bank leaves it with you and they make money. So when they get the money back, there's more money. So it's the same kind of idea. But you're not I guess gaining from it. They are gaining from it. Okay, so that's why they reward you for leaving your money in the bank, because if you leave the money with them, they can give it to, like, so say if this is, I don't know, Joe, okay, and this is I don't know, Cameron or something, okay? So Joe is leaving money in the bank, and then she's going to leave it there, and eventually she knows she can take it out and get more money. So when she leaves the money in the bank's got money to give to Cam, okay? So that's why they'll like reward you if you, leave your money in the bank, because then they can give it to someone else and they can make money because they're going to pocket this extra 25 or whatever that they made, okay? So So the bank will give money to Cam. The Cam will use it to start up their business and then start making money. But then Cam's got to give that money back. Okay. So while he had it for uh, 4 years, okay. Well, Cam had it for 4 years. There was some interest that accumulated on it. So when he returns it, he has to pay back more. Okay, so in this case here, it's like the bank made money here, okay, by doing this process. So, all right, so anyway, that's what we're going to do with this problem, except it's Alice. Okay, so I'll leave those pictures there. All right, so let's go through and figure out how much she's going to have, how much the bank's going to have at the end, okay, because of, so maybe I'll change this to Alice, okay. Alice has this money, okay, and we're trying to figure out like how much interest and so forth and how much money here they'll have at the end, okay? All right, so let's go through and figure out all the stuff that's given to us. So we have Alice who borrowed $5,000, okay? So that's the initial amount, so that's the principal. That's the present value. So right now the loan is worth $5,000. Okay, and the interest rate, there it is. So I don't know, we'll call it R, is 9%, and it's compounded monthly. Okay, so if you know it's compounded monthly, the compounding period is 12. Okay, all right, she has to pay the loan back in 4 years. So remember how we kept our money in and then we come back after 4 years? So we're going to let Alice hold the $5,000 for 4 years and then she has to pay it back. Okay, so we're trying to figure out how much she has to pay back in A, and then how much interest, like how much extra money did the bank make off of Alice borrowing this money? All right, so let's start with finding I. So we have a compound, because we know it's a compound problem, compound interest problem, because it's compounded monthly and so forth, okay? All right, so interest is, remember, take the decimal, take the percentage and change it to a decimal by divided by 100, and then we're going to divide by the compounding period. So that's 12, okay? So basically, the bank is going to, every month, charge her interest, okay, that she has it for. So you end up with a percentage of, okay, 1, 2, 3. Okay, so you end up with a percentage like that. Okay, so if you're looking at, it's like 0.75% every month she gets charged interest, okay? All right, so then, and then, remember, she has this money for 4 years up here, okay? So if she is being charged interest every month, so that's 12 times in 1 year, and if she has to have interest charged her for 4 years, how many times does the bank charge her interest? Okay, so 12 times 4 is 48 times the interest goes boom, boom, boom on her $5,000, okay? All right, so we know it's 5,000. We know the interest every month. We know how many times in the 4 years, 48 times. We are now going to calculate how much she has to give back to the bank at the end, or you can think of it from the bank's perspective. How much does the bank make off of Alice? So let's get to the compound interest problem here, or the formula. So here's our plan. We're going to use this formula in order to calculate the total amount that she has to return, okay? So again, the initial amount is 5,000. Okay, 1 plus I, which is 0.0075, and the exponent is 48. Okay, compounded 48 times. All right, so go through. Again, BEDMAS says do the brackets first. Okay, and then you're going to do the exponent here. Okay, so again, just a reminder, do the exponent first, okay, or do the brackets, then do the exponent first. So I'm just gonna, oops, okay, so we have 1.0075 to the exponent 48. Okay, and then we end up with 1.43. So I'm just gonna write that in. Just to remind you, don't use the 5,000 yet, okay? 1.43140, etc., okay? So that, and now you're going to multiply the 5,000. That's the last step, Okay, so then go times, so just keep it in your calculator, times 5,000 equals. Okay, so again, it's the stuff. It is straightforward. I just find that every year students just have issues with just using the formula correctly and calculating things in the right order. Okay, so this is why we've been practicing bed math for so many months or weeks and with a lot of things, so that you guys can be good when you have to uh, work through several operations like this. Okay. All right. So now again, I wrote down all of the digits again just to help you practice rounding. Okay. Sorry, this is a 0 here. From there, remember it's 2 decimal places if it's money. So you know you got to keep this digit. So you're going to look at the next one, and these are the ones you're going to dump off. But before you do that, oh, it is bigger than 5. So that means I got to round up the 2. Okay. So then my final answer should be, so this is my total amount that this is the total amount that Alice has to pay back to the bank. Okay. So okay, and so 3 cents like that. So we got to get every little digit correct, every down to the cent. Okay. All right. So you're looking at that and going, wow, yes, she borrowed 5,000, but had to pay back a lot more money when she was done. So now we're going to go through. Now that we did that, we're going to answer A. How much did Alice have to pay back? Okay. So A, Alice had to pay back. Okay. So $7,157.03. Okay. And then B says, well, how much of, so basically she had to pay back all of that back because she borrowed 5,000, but then she had to pay back that amount, $7,157.03. So in the end, B asks how much of the amount was interest. Okay. How much of it was interest? So what you're doing here is you're just taking the total amount that she had to pay back, and you're subtracting it by the amount that she borrowed. Okay, and then you'll figure out how much extra the bank made. Okay, so the bank ended up making, so 4 years they let her borrow 5,000. So they ended up making $2,157.03. Okay, so that's the interest that the bank made. So you're going to find that, yeah, when you're looking for a bank to leave your money in, you want to always look for the highest percentage. And compounding periods, pay attention to that. Lots of compound periods, lots of times where the interest will go on. That's great for you. But if you're going to borrow money, you want to do the opposite. You want to find something that's not a high percentage, and you don't want compounding, a lot of compounding either. Okay, so just kind of try to look at that when you're going in and looking at a loan and so forth. Okay, so just be careful. Be able to calculate out how much you're going to owe and so forth if you're going to buy something big. Okay. That takes us to the end of the compound interest formula. So we're using this one today instead of using a table to calculate all the values out. So it is convenient because there's a little bit of writing, but definitely when it's many years where you're borrowing money or keeping money in a bank, it's you don't have to calculate as many numbers. Again, so the new things here are like the interest rate and the interest per compounding period and the number of compounding periods. Make sure you do those properly. Again, it's just about the interest rate, but then if you are breaking it apart over monthly or quarterly, you need to divide it by certain values to figure out how much the interest will be per compounding period. And then the N will be, again, if you have to pay interest or get paid interest like twice a year, but then you keep your money in this account for 7 years, that means it'll be added 14 times. So you need to calculate that as well. Okay, and then from there, the rest of it is just plugging it all in and following bed maths. Okay, so again, do the brackets first, do the exponents next, then multiply this number out. Okay, and then you're good to go, and then just make sure to write a final statement. All right, so go practice some questions and then try the checkpoint.